Hello everyone. Today we shall be discussing on how to calculate or resolve vector forces acting on different angles. Once again, resolving vector forces acting on different angles. Now, for example, we have multiple vector forces acting on diverse and many angles from the body at the center here. Now we have 3 Newton acting this way, 5 Newton acting horizontally here, 2 Newton acting downward here, 4 Newton acting down here, where we have our horizontal axis over here and our vertical axis. Now, to resolve the forces over here, now let's start with the vertical axis first. To resolve our vertical axis forces, now to resolve 3 Newton vertically, we have 3 cos 60 because there's an angle of 60 in reference to its vertical position. Now, to resolve our 2 Newton, we have negative 2 Newton cos 45 because the forces is acting downward. That's why we have negative. Now, to resolve 4 Newton, we have negative 4 cos 30. For the fact that it's acting downward, we have negative cos 30. So therefore, by inputting all these entries into our calculators, we have minus 3.3783 Newton. Once again, by inputting all the references of the forces that we resolve vertically here, we have minus 3.383 Newton using scientific calculators. Now, let's go on by resolving our angles horizontally. Once again, let's go on by resolving our angles, our vectors horizontally. Now, we have 5 Newton acting negative direction. So therefore, we have minus 5. Then by resolving our 3 Newton force here, we have plus 3 cos 30 plus 3 cos 30 because it's acting horizontally. Also, by resolving our 4 Newton, we have 4 cos 60. 4 cos 60. Then by resolving our 2 Newton here, we have minus 2 cos 45 because the angle in reference to it is 45. Likewise, 30 degree here for 3 Newton. Likewise, 60 degree for 4 Newton. So therefore, by inputting all these entries into our scientific calculators, we have minus 1.8161 Newton. So therefore, to calculate the resultant vector forces, then we input our vertical and the horizontal input by squaring both sides and by adding it inside a square root. So therefore, our R equals square root of our vertical raised to power 2 plus our horizontal raised to power 2. So therefore, we have resultant equals the square root of 14.711. Our resultant forces equals 3.8 Newton. 3.8 Newton. So therefore, to find direction of our resultant forces, of the all vectors we have over here, then we can calculate it by using the formula of theta equals tan arctan into bracket vertical resultant forces over horizontal resultant forces. So therefore, we have our theta equals arctan minus 3.3783 over minus 1.8161 into all brackets. So therefore, our tan from here equals 61.7385. Now, let us look back to the sign we have here. As we can see, these signs are negative. So therefore, the two resultant forces lies on the third quadrant. For the fact that they are negative, lies on the third quadrant. So therefore, now for us to have 61.7385, we have to put addition of 180 degree of the first two quadrants by adding 180 to the angles that we have. So therefore, the direction of the resultant forces will be theta, which equals 180 plus 62, which equals 242 degree. Once again, our direction equals 242 degree. Thank you.